All right, class, this video is going to help with 10.3. So again, we're working on these derivatives. So 10.1 was like kind of a review of ease and continuous interest. And then 10.2 was the logs and doing the derivatives with some of those ease and logs. So then 10.3 is like, how am I going to take the derivative of something if I have times or division that I cannot simplify? So we know we could simplify some things and then do our derivative. But what if I can't simplify? Then I have these rules right here. Okay, so our product rule goes, all right, derivative is equal to, I have the first function, right? If I have something written first, so it's going to be a function times a function. So whatever they are, they're times each other. They could be in parentheses. They could be e to the x times something. It could be whatever. And then what we do is we're going to have that original first and that derivative over here. And then for the second function here, we're going to have the same idea. Here's our second function times the derivative in the original and then the original. So you can see you have original derivative, and you add them. Okay, so basically it'll be first times the derivative of the second plus the second times the derivative of the first. Okay, now same kind of idea. If I have a fraction, I have top and I have the bottom. Okay, so the way this one works is you're going to have the original bottom times the derivative of the top, right? So original bottom, derivative of the top, minus, so you have to be careful. We start with bottom, 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 original bottom. So it's low d high minus high d low, all over low squared. There's like a little song. You can look it up. I'm not very good at it. Okay, and then the second one would be original t times our bottom's derivative. So as long as you remember to start with the original bottom times the derivative of the top, then the rest will kind of follow. It's like then a minus, then the original top and the derivative of the bottom, because you know it has to be the opposite. And then the one is the bottom squared. Okay, so when we did this with the 3-step or 4-step process at the very beginning of the last chapter, we did this a lot, and I could look at it and be like, okay, yeah, the bottom will be squared. And we always ended up with doing this, but you know, I couldn't show you the shortcut at that point yet. Okay, so let's do a couple. Now this first one, could I easily times this one through? Yes, but I'm going to do the long way because I'm not really sure why they didn't give us a problem that we had to use the product rule for, but let's do this one. We don't have to. We could times this through, but we're going to use it. So our first term, right, is 7x to the 6th. Then I need the derivative of that first term. That is going to be 6 times 7 is 42x to the 5th. Okay, so I had to do the first and then the derivative of the first. And then I'm going to do the second. Okay, so the second term is 3x to the 3rd plus 14x minus 10. And then the derivative of the second is going to be, well, 3 times 3 is 9x squared plus 14. Okay, then we'll put it together. Up here it says to start with our original first. So we're going to go original first. So this is the derivative of the whole thing. Original first is 7x to the 6th. Okay, and then we're going to times that by, I just use parentheses for my times, the opposite one, the derivative of the second. So 9x squared plus 14. And then this one's a plus. So product is plus. It always is plus, right? In logs, product is plus. In exponents, product is plus. So, yep, plus, plus. Okay, then we have our other way. Original second is 3x to the 3rd plus 14x minus 10 times the 42x to the 5th. It doesn't quite quite look like a 5. So we'll go this way. It still doesn't look like a 5, but I don't know if I could make it look any better. Okay, and then we can simplify this, and then we've got our answer. So this is 42x to the 5th. There we go. I didn't like it. It didn't look like a 5 at all. So let's multiply this out, and then we have our answer. So derivative of this is going to equal 7 times 9. Why can't I think of 7 times 9? 63. I don't know. So 63x. So we're timesing. We add our exponents. And with times 6, 7, 8. So we have x to the 8. And then 7 times 14 is 98. So that's plus 98x to the 6th. All right, then over here, I got to times this by all 3. So plus 42 times 3 is 126. X to the 5, 6, 7, 8. And then 42 times 14 is 588. Positive, right? Yep. X to the 6th. So you have 1 and then 5. And then 42, it's a minus. 42 times a negative 10 is 420. And then x to the 5th. Yuck. We do have a couple terms we could combine. We have 2 of them to the 8th and 2 to the 6th. So 63 plus 126 is going to give me 189. X to the 8th, and I got those 2. And then 588 plus 98. 588 plus 98 is 686. X to the 6th minus the 420, x to the 5th. Ew. There we go. Now, I know multiplying this one out originally would have been easier, but I have to show you the steps because you have to know this process. So problem 2 is the same. I really could multiply it out, but you could think of this as first, this is second as well. I thought there was one more. Hold on. I'm just going to look real quick. Yeah. So I'm going to skip 2 just because it's so similar. Let's look at 3, quotient rule. So our quotient rule says that you take the derivative is equal to original bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. That's kind of the shortcut. And I think they wrote that for you. Kind of. BT, yeah, they kind of did. There's kind of your shortcut. They do give that to you like that, though. Okay, so our bottom, let's go ahead and do our bottom, is going to be 5x squared plus 13. What's the derivative of that bottom? It's going to be, well, 2 times 5 is 10x, and then the 13 drops off. So then the top original is 17x, and the derivative of the top is just 17. Okay, now we have our 4 things, right? So we can put them in. So we start with original bottom, 5x squared plus 13. And then we're going to times that by the derivative of the top, which is just 17, minus the original top, which is 17x, times the derivative of the bottom, all over the bottom squared. 5x squared plus 13 squared. And this we should label is the derivative of the whole thing. Now, on a lot of these problems, they don't even make you simplify. They're like, done, this is good enough. They just want you to know the process. Because here's the thing, if I can take the derivative and then I can put in a number for a function, I can find what I'm looking for. So a lot of times you don't have to do a lot of simplification. But the simplification on this one's not too bad. You just distribute the 17 times these and then look for any common terms. Don't multiply out the bottom for sure. Okay. Let's do that again because I definitely find the product rule, I keep saying the product rule, the quotient rule a little bit harder than the product rule. So again, top is 2x minus 5, and the top's derivative is just 2. Okay, bottom's derivative, or bottom, is 3x squared plus 5. Bottom's derivative is what, 3 times 2, 6x, no more 5. Okay, what do we start with? And you could pause and try it real quick. See if you get my answer. What do we start with? Our original bottom. Okay, original bottom. So 3x squared plus 5. And then this bottom will have to be times by the derivative of the top, which is 2. And then minus, and then the original top is 2x minus 5. And I'm using all my parentheses for my timesing. And then we did original top, so derivative of the bottom is 6x. Okay, and that's all over the bottom squared. Okay, so then we're all over the bottom squared. Done. I could simplify. I don't have to. Okay, let's do another product rule on something I would actually have to use the product rule for. I mean, I have no way around for the product rule on this one, and it brings in some logs and some e's as well. So our first is 7 e to the x, right? And so the derivative of the first is 7 e to the x. Well, that was a hard derivative. E to the x stays e to the x, 7 stays there. And then the second is 7 natural log of x. And then the derivative of the second, okay, we keep the 7, right? And the x goes on the bottom. So 1 over x is the derivative of natural log, but you got to keep the 7 on the top. So product rule says, does it say first? I want to follow, I just know they're plus, you could do them in any order. So first. I want to follow what they say just because. So first, original first. But really, I just know it is original first times the derivative of the second, and then these two. So original first is 7 e to the x, and then times the derivative of the other one would be 7 over x plus, so we can, that's why we can mix them, is because it's plus. And then we have to do our original second one, 7 natural log of x times the derivative of the first, 7 e to the x. I don't know that we can do much simplifying on this. You could think of this over 1. So 7 times 7 is 49 e to the x over x plus 7 times 7 is 49 natural log x e to the x. And you might want to keep your parentheses here or put a time symbol in between when you type them in so that it's not saying natural log x e to the x in 1. Or you could write the natural log x at the end like we did with the other one. But this is our final derivative. Okay, that's getting a little ugly. We really could times that one. We've already seen one like that. Do we have any other tricky ones? Yeah, let's do 8. So 8 is again another times 1. So our first is 7 to the x. So what's the derivative of that one? Do you remember how to do the derivative of that? It stays 7 to the x times natural log of 7. So e to the x is really e to the x times natural log of e, but the natural log of e disappears to 1. So, okay, so second is log base 5 of x. So now we have to do the derivative of our log. So the derivative of log was 1 over natural log of 5 times 1 over x, which we can rewrite as 1 over x times the natural log of 5. Okay. So there's our stuff. So we start with our first. So the original first is 7 to the x, right? Times the derivative of the second, which is 1 over x natural log of 5, plus the original second log base 5 of x times the derivative of the first 7x times log of 7. Okay, simplification Really, the only thing you could do is possibly write this right here on top because it's over 1. And then that plus the other side you could leave that way because you can't really do anything but write them next to each other. And it should take that answer. It might take it just like this. You might not even have to times excuse me, I added the first two together. Okay, look at this hairy one. Let's simplify this a little before. So think of this as 8, and then what power will that x be? Fourth root would be 1/4, okay? Because the power on the x is 1. If it would have been x squared, it would have been 2/4. If it would have been x to the third, it would have been 3/4. So hopefully you're getting better at those. Okay, we're here. Now, derivative, we know we have to do top is equal to 8x to the 1/4. So the top's derivative is 1/4 times 8 is 8/4, right? And I mean, you could reduce that if you could have thought of that. And then 1/4 minus 1, 1/4 minus 1 is -3/4. So I think 4 make a whole, so I'm minusing 1. I got 3 left. However you can get that. So bottom is x squared plus 4. So bottom squared derivative is 2x. Okay, so let's put this all together. What do we start with for our product or our quotient rule? Is original bottom. Okay, so original bottom. So x squared plus 4 times derivative of, so other one of the top, 8. Oops, I'm going to write that. I don't want to type that in as 8x. What does 8x equal? 2. So 2x to the -3/4. Could you have wrote the -3/4 in the denominator? Got rid of the negative? Sure. And then x to the 3/4. Would it have become x to the third, fourth root? Yes. So there are other ways to write that term. Whatever way you choose is absolutely fine. And then we have a minus. Probably should have wrote this at the bottom so I could fit it all in here easier. And then we have our original top, which is 8x to the 1/4. And then we're going to times that by the derivative of the bottom, which is 2x. It gets like smaller. You barely read my 2. Okay, and then it's the bottom squared. Okay, again, simplification isn't something we always have to do. So you should be able to put it in like that on most of them. But even on the exam, there will be a question where I just say, do the quotient rule. You don't have to simplify. Okay, I think, okay, let's do one. Well, if you have one like 10, so 10 has a quotient in a product rule in a quotient rule, but it isn't mandatory. You could multiply this out and then do it. So I'm not too worried about that one. So multiply it out, simplify it the best you can. Always simplify it, then do your rules. It'll just make it easier. So you don't have to use the quotient and product rule unless you cannot simplify and you're stuck with a fraction or two things you can't multiply, like a log and a e, or something like that, two different terms. All right, hopefully you find this helpful.